Our next presentation comes from Joost VandeVondele from CSCS.
Yep. So, good morning, everybody. I'd like to present you a little bit of information on the Swiss AI initiative, which is a new initiative in Switzerland that we will also leverage to provide community access for machine learning on ALPS. Now, I was asked to give this presentation yesterday, and so I was actually wondering, how should I approach that? I will be the first speaker, the last speaker of the morning session just before lunch, and how could I capture the attention of the audience? And then, ChatGPT gave me the answer what I should do. I could ask a thought-provoking question, but looking at that question, I think it's quite clear that, AI has revolutionized the field. We are all convinced of that. Or it could share an interesting statistic. And then I actually thought, yes, I've seen a very interesting statistic a couple of weeks ago. And so ChatGPT did its job. It helped me to recall something useful. And I recalled this graph that was shown at the Applied Machine Learning Days by Salate, actually making the point that Switzerland has something to offer in the field of AI research. If you look at the number of papers published per capita, Switzerland is doing at least twice as well as the big players in this field that we think are China or the US. So Switzerland is very productive science-wise per capita in this field. Now, what is a timeline or some of the announcements that basically created public attention? And I think there's 3 years on this graph. For me, this first announcement is very important. CSCS announced, together with NVIDIA and HPE, that we would install a new system that would be one of the world's most AI-capable supercomputers in the world. And I think this announcement didn't receive too much attention, certainly not comparable to the next announcement in this timeline, namely that OpenAI introduced ChatGPT. And that is just 1.5 years ago, November 2022. This was announced, and it took the world in a storm. And then a little later, November last year, the ETH and EPFL announced the Swiss AI initiative, a joint initiative for trustworthy AI. And that received a lot of attention in Switzerland and basically was the start of the Swiss AI initiative, which I would like to introduce to you today. I will do that initially based on slides presented by Professor Antoine Bosselou, who introduced the AI initiative at the AI House in Davos during the World Economic Forum last year. And basically, he started, first of all, of course, acknowledging that Gen AI is a computing revolution, but also that this technology is not without problems. And he pointed out 3 issues. First of all, the fact that at this point it is very undemocratic. The real power on Gen AI is limited in a few places in the world, you could say countries, or also large corporations. We don't quite know how they are developed, how we can control, how they are aligned, and so how they answer. Also, they are not truly trustworthy. People have been showing, jailbreaks of these models where you basically trick them into doing something they should not do. And in this case, by just asking them to repeat a word indefinitely, they actually divulge personally identifiable information like email addresses and telephone numbers. And then also, they observe that, the society is not truly ready to accept that technology yet, or at least, there are things ongoing like lawsuits. Can you use my data, or articles published or videos uploaded to YouTube to generate models that might generate movies or other aspects. Where they see their role is in the where academia has been traditionally pretty good, namely having a bit of long-term vision or addressing challenges that are not in the immediate economic interest of the large players, so have a room for systematic investigation of AI, Can we really understand what is limiting them today? What is, the importance of, for example, reasoning capabilities? Can we introduce the transparency, have transparent releases of these models? We know that, companies like OpenAI had, initially this very open perspective, did release their models. You can, run ChatGPT 2 on your laptop, but not longer 3, 4, 5. Also, of course, for, due to the fact that the resources needed to run them today are very large. But also, science can focus on areas where AI could have a great impact, but maybe the economic value is less, and companies will not focus on this immediately. And, for example, education or certain aspects of health or science could be an element there. And so, summarizing this, the Swiss AI initiative wants to develop, capabilities and know-how and talent in Switzerland, because it's academic. We have to teach students and, the workforce of the future to be able to generate, to create Gen AI aligned with Swiss values. So not, just Bay Area values, but also, the Swiss values. And then make these resources available to the Swiss society, but also to global actors. The way they see that, and this is how CSCS comes in the picture, is this loop around the infrastructure that we can provide with ALPS. ALPS is indeed very well suited to train these large models, and they have various phases in this development. They want to create foundation models, also large language models, have human AI alignment steps there to align to Swiss values or to focus on applications of societal value, have red teaming efforts to make sure that, the harmful or potential harmful sides of these networks are under control, and deploy them and actually have feedback of on these models. They have identified various areas where the Swiss AI initiative could act: education and training, scientific advancement, clinical and public health, climate and sustainability, and then perception or robotics. What is, I think, very interesting there, and why it's also important that this is going beyond what we've been doing so far at CSCS, namely where individual PIs could come for a grant, is that they have realized that a lot of these challenges are out of reach of single PIs. The community has to come together to tackle these grand challenges, and that is what the Swiss AI initiative is trying to achieve. So they have basically collected about 80 professors in Switzerland that have expressed this interest, and they're basically focusing their resources on a few grand challenges. And also, I would say, for one of the first times, they have realized that this kind of topic needs to have impact in society, and for having impact on practical problems, it is key to also have the universities of applied sciences join this project. And so you see, for example, ZHAW or other of these schools joining this initiative. Now, when we say, okay, these academics want to generate models based on open data and so on, can they actually compete with the big players? And here is one example. This is a few of the professors. It's still not based on calculations done at CSCS. This was preliminary work, but they had an early success in making a large language model that was focused on answering questions of medical relevance. And how they went along, they took an existing open model, I think it was Llama 2, 70 billion parameters, and on top of that, they did fine-tuning based on open data, namely abstracts of papers in the medical fields and guides that you can have, medical guides that are, the World Health Organization publishes that, and on top of that, they added this to the data set. Then if you look at this graph, you can see it is right now the best performing open model for answering questions in the medical domain. And it's actually quite competitive with, much larger models, like, the first version of MedPalm, and it's roughly on the quality of GPT-4, a little bit below that. So you can indeed still be competitive to a certain extent in this domain, by this kind of academic open source efforts. But one very interesting collaboration here was then work by Annie or Marie-Anne Hartley, who took this model, and she has an interest of making such models or such tools available to developing countries. And so she took this model now to doctors in Africa and is working on trying to make sure these models are free of bias. And for example, she gave an example of the questions. If you ask whether black people can have skin cancers, some models might be with a bias and say, no, it's not possible, while other sects actually that are properly aligned can give the correct answers there. And so this is now being deployed in Africa. There's actually tens of doctors that are giving feedback on these models, on the quality of these answers in that setting, and the model is being improved to be valuable there. And I think it's very interesting to see that, with relatively little effort, because this was, a training, a fine-tuning done before we had ALPS, you could have a very big impact in society. Now, let's get a little bit. This is an initiative that was, created basically last year, and it's not yet running since ALPS is not yet operational. It has been announced in roughly December. There's a website online where you can see who are all the partners in this initiative. And we basically decided to help kickstart this initiative with an initial allocation on ALPS on the order of 10 million GPU hours. If you've seen the numbers today in a few of the presentation, that is enough to be able to train from scratch smaller models on the order of 70 billion parameters. And that's one of the goals of the initiative. Now, funding-wise, the initiative is still in development. As I mentioned before, 80 professors have committed resources from their sides, typically said we can dedicate, a couple of PhD students or postdocs to this initiative. And the idea is, of course, that there will be matching funds from academic and also private entities. And, this is still work in progress. The first funding line has been secured for the next 4 years. The ETH domain will actually fund this initiative. It must be said that this is a very visible initiative. I think, CSCS has been in the news in the last year, much more, I would say, than in the few years before. It's also very visible to, the vice presidents of the ETH and other players in the ETH domain. And so it's important that we deliver on that. That, it's not just hot air, but actually that we are able to land a few serious applications of Gen AI in this context. One other example, which is, I think, also very nice to see how we can make impact, is that there was another meeting at the World Economic Forum where a network has been established. It's called the International Computation and AI Network, or ICANE. And this is a network focused on giving resources to developing countries to develop and test AI models to specifically advance the United Nations Sustainability Development Goals. And CSCS is one of the players that will actually be providing the infrastructure for this initiative. Now, what do we have so far? We are building a machine learning platform using a lot of the technology that has already been presented by various speakers of CSCS. So the machine learning platform will be based on the vCluster technology. It will be dedicated and tailored for the machine learning community. At CSCS, we don't do the data science. This will be the part of the problem that is really addressed by the domains. But we will focus on the effective training of models at scale. This is going to be container-first technology. And for us as well, this will help us actually design the infrastructure. So right now, ALPS has been designed pretty nicely from the compute side, but we have still to improve, for example, the storage side, and there some of the interesting test cases will be developed in this context. Initially, the first round of access we had already from users. They have been using A100 and MI250 GPUs, but of course right now we're waiting on the scale-out with Grace Hopper GPUs, and also future additions of MI300 GPUs. And so that upgrade is right now pending. Been meeting with users in a very dynamic way. I mean, I think this has been already mentioned. This field is evolving very, very quickly. Basically, you have to be able to respond to their requests, on a week time scale, because in a few weeks later, that new ID might already be outdated. It's quite amazing to see how short the time is between a paper appearing on archive and 2 weeks later, students that really want to use that new technology in their models. Even though resources are very limited, the community is indeed large. We have had calls with the community that had 40 or 50 students interested to understand how to train on the machine. And the groups have started to adopt, to create their data sets, to basically adapt the code bases, and to start, judge the system performance, even though, of course, there we wait on the Grasshopper scale-out. There are about 10 domains in this initiative. There are 5 horizontals, as we say it, and about 5 verticals. The horizontals are there to create technology, methods, algorithms, software that span various application domains, but can be reused by these verticals. And for example, there is a horizontal that will focus on large language models, purely on text. There is a horizontal that looks at multimodal models, so both, for example, text and images or video. And there is, as I said, the red teaming or the conversational aspects. And then there are verticals. We have the vertical on sustainability and climate. There is a vertical on health. There's one on vision and robotics. There is one focused on education. And there's one that looks at the use of AI in science. Now, I picked just 2 to give an example. I don't want to cover all these areas. One is the area of sustainability, or the vertical on sustainability, which will focus on producing a foundation model for the Earth system. I'm borrowing here slides from Professor Shem. What they have done right now is they have basically ingested data sets such as CMIX6 on Clariden, and will also be using the ERA 5 data sets. These are interesting for us. They are, combined petabyte-sized data sets, so we will learn how to do training on fairly large data sets. And eventually, this will evolve and also include streaming data, for example, from simulations that are ongoing at ICMWF in Bologna, or also simulations that we will do locally. And some of the presentations, I think Thomas' presentation, pointed at that, these very high resolution data sets that we will generate with ICON on the system. And for us, and this I highlighted there, is this is the project with which we will learn how to design the I/O system of ALPS, large amounts of data, streaming amounts of data. For the scientists, one of the challenges there is basically combining the data sets of various sources. These models have different grids, different resolutions. How do you train with all these different data sets one model basically that can deal with them at all? The second area I would like to cover is the area of health. For this I borrow slides from Professor Rech. They want to have medical data, and they have 3 different areas. On this slide, there's a 4th area that I didn't couple. For example, they want to have data from intensive care units, the signals that they measure, your heartbeat, your respiration, whatever kind of physiological parameters that are measured, and use that in a predictive way, for example, to say organ failure might occur in this patient in the next 4 hours. We have to increase the attention to this patient because something bad might be happening. They have also worked on this. For example, they have already collected data sets for more than 400,000 stays. So patients that were in the ICU for a while, they have been measured. This data is completely available. And that is quite interesting. A second problem is, for example, digital pathology, where they will be looking at images that they have collected. When, for example, you have a slice of skin, people look at the cells, will be able to segment the cells into healthy or unhealthy cells, and also there you would like to be able to create a model. This is then, instead of like one-dimensional signals, these are now two-dimensional images, fairly large size. These are, gigapixel-sized images, but, a smaller number, a few 100,000 images they have been collecting so far. And the third one would be a multimodal medical LLM, in this case, focused on CT and similar image analysis, where they would like to have a kind of an assistant for the less experienced radiologists that, would be able to basically show the images that have been just taken, and this radiologist could be able to have a conversation with this assistant, basically helping to see whether, there would be a chance for rare diseases that this radiologist might not have yet seen. Now, all these applications handle, of course, sensitive data, and partially, there might be personally identifiable information. And I think this is also for us kind of a challenge. The large volumes we will have with different projects, but sensitive data handling is something that we will learn with these projects. Finally, we have been looking at this topic also internally, trying to make predictions about how our resources will be used at CSCS. We have for a very long time, we focused on computational science and engineering simulations, and we see now that, weather and climate and big data and machine learning and their data, typically not yet that big, will be a sizable fraction of our resources, and we expect that going forward, probably 45% of our resources will be the modeling and simulation, 45% of our resources will go to this machine learning and big data analytics problems. We see a large new user community coming to CSCS. These 80 professors, the majority of them have never been at CSCS before. They have previously been doing calculations in the cloud. They know how, you can use whatever Google credits to do some smaller scale training, but they haven't had the HPC experience that we offer, and so we're learning there. With this, I would like to thank you for your attention, and I'm happy to answer questions on the Swiss AI initiative.